Francium Incorporated is on a journey to digitally transform many parts of its business in order to remain a leader in its market. Francium is becoming data-driven to help make decisions. However, it is becoming apparent that they have multiple applications in data silos that are not connected, leading to error-prone manual processes and limited data for analytics and decision-making. As part of their digital transformation, Francium would like to integrate their applications and data sources, modernize their procurement processes, synchronize important data records across applications, enable customers and vendors to digitally interact with the company, and empower their employees to find and use data without delay. Francium, like many businesses, utilizes a combination of cloud-based and on-premise applications. They also have on-premise databases, data storage, and are starting to use cloud-based storage and services. Here are Francium's key digital transformation initiatives. Automate their order-to-cash processes. EDI modernization. Synchronize critical data across applications. Create a public-facing API for order creation from a mobile application. Create a user workflow for easier and quicker access to business data. And implement a data catalog allowing self-service data discovery. Join us for this series of videos and interactive demos showcasing how Boomi's Atomsphere platform enables Francium to achieve its digital transformation goals quickly and easily. Francium's orders are placed in one system, but need to be transferred to another to complete sales. Not only is this manual process time-consuming, Francium is also prone to making mistakes while transferring their orders from their CRM to ERP, resulting in both time and money lost.
Starting with the integration layer of the Boomi platform, let's build a process to connect their CRM and ERP systems. For this specific demonstration, we will use Salesforce as a CRM and NetSuite for the ERP, but these could be any CRM or ERP systems such as SAP, Microsoft Dynamics, and others. To begin, we'll want to connect to our CRM. Every connector in Boomi has the same two-part setup, a connection and operation component. First, let's establish connectivity. In our example today, we'll be connecting to Salesforce, and all we need is a username and password. Next, we'll need to configure the data that we would like to retrieve from our CRM system. And this piece is handled by the operation component. We can do this easily by leveraging the import wizard on our connector that lets us browse the available objects pulled directly from the CRM system. On the CRM side, Francium is trying to synchronize new customer accounts and sales opportunities to a sales order entry in the ERP system. In Boomi, logic is built into a process, which is the core of all functionality. We use our map shape in order to do the data mapping between two various formats. From here, we can leverage Boomi Suggest, our mapping AI functionality, to help speed up the data mapping process. With all the components configured, the last step is to connect all the pieces together for our process to be completed.
Francium has been using a third party for their EDI order placement. As they digitally transform, it has become apparent that the third party is too slow to make changes, and Francium has limited visibility when issues arise.
Using Boomi's EDI or B2B functionality, let's build a process to connect Francium's trading partners to their ERP system. Since we have an existing integration connected to some of these applications, we can use that process as a starting point. By simply changing the start shape to a trading partner type, we can begin configuring our trading partner shape. Just like the integration layer, the EDI component is all configuration based. We'll first need to choose our communication method. From there, attach our company to the My Company section, and can then begin setting up our own standards. The last important piece for our company configuration is establishing connectivity to where our EDI documents are stored, as well as where incoming documents should be stored. Boomi supports AS2, FTP, SFTP, HTTP, and disk communication methods. Once the communication method has been established, we can begin setting up our trading partners, which is a very similar process. The X12 and communication tabs are identical. Firstly, configure the ISA and GS fields, and then go on and configure the various communication methods you would like to establish for the respective partner. Boomi provides the full selection of EDI document types, allowing you to specify which transaction sets you will be exchanging with each partner. With our trading partner shaped, fully configured, we can begin cleaning up the rest of our process. As you can see, the trading partner shape creates 3 branches. One for processing the actual EDI documents, another for acknowledgements, and the last branch is there for error handling. Since our CRM connection will be replaced by the trading partner shape, we can delete the Salesforce shape on our canvas. And I'm going to add some simple logic before we actually process the EDI documents. By leveraging a business rule shape, I can create a simple rule that will help facilitate the EDI documents coming in. By selecting the PO104 field, which represents a unit price of a purchase order, I'll create a simple condition requiring that the price is not empty. After that, an accepted and rejected path is created. For the rejected path, I have a few options in terms of how I want to handle this incoming data, but for now I'm just going to use an exception shape in order to capture the document level errors. So for the last step, we'll want to update our map shape. For this, all we need to do is swap out our previous CRM account profile and change it to our 850 purchase order profile. We can leverage Boomi Suggests to expedite the mapping process. And once that's complete, I'll drag and drop another trading partner shape and connect that to the acknowledgements branch. And for now, I'll simply add a stop shape for the errors branch. And with that, we've easily converted our integration process into an EDI process.
Francium, like many businesses, has multiple applications that run the business. One of the challenges is keeping important data that is common across these many applications up to date. This has caused issues in the past. For example, shipping products to a customer's old address.
While Boomi's Master Data Hub can synchronize any data, for this example, we'll be focusing on synchronizing customer addresses. We can begin by repurposing our integration process again to handle this new hub integration. For this, we'll have a 2-process setup with Master Data Hub sitting at the center of all our applications. Process 1 will be from our CRM to Master Data Hub, while process 2 will be Master Data Hub to our ERP system. Let's start the setup of our second process. The beauty of a unified platform allows us to reuse existing components that we can leverage when configuring Master Data Hub. I can copy my NetSuite shape and paste it into our second process. And all I need to do is update the operation to reflect the customer data type that we'll be mastering. Switching over to the MDH layer of the platform, we can start setting up the customer golden record. Firstly, let's establish a new source, that being NetSuite. Sources represent a system that contributes to the master data. I already have one set up for Salesforce, so we can skip that. Next, let's define our customer model. Each application has its own data format. In this example, our CRM uses account or account name, but our ERP is expecting customer or customer name. A huge benefit of Master Data Hub is being able to translate these different languages the applications use, thus keeping them in sync. Model creation in Hub is configuration based, just like every other part of the Boomi platform, and each layer builds on top of each other. We can use the profile generated at the integration layer to give us a great starting point. When defining your model for your golden record, it's important to only choose the fields that are most important for every application needing to receive this data. So by leveraging our customer profile generated by the NetSuite connector at the integration layer, we can pick and choose the fields that will be present in both our CRM and ERP to define our customer model, or should I say our customer golden record. Next, we'll attach our sources for this respective model. And from here, we can move on to setting up a data quality step. Data quality steps allow us to add an enrichment and validation layer, which ensures the data will be trusted while being kept in sync across all applications. We have a few built-in services like Dun & Bradstreet for company verification and Locate for address verification. But if these services are not what you're looking for, you have the flexibility to create a Boomi integration process connected to any API, like a free weather API as an example, and leverage that as a data quality step. For this example, I'm just going to use our Locate service for simplicity. Next, let's make a simple match rule. By configuring the match rule to match on name, if two datasets come in with the same name, we'll treat them as the same record. Typically, more match rules are recommended in a production setting. But once that is all complete, we can now publish this new model. Now that our customer golden record is ready, we'll need to build a process in order to push the data into Hub. For that, we can leverage our MDH connector, which operates the same as every other connector in the platform. For the operation, we can browse the available models and use our newly published customer model. With our endpoints established, the last step is to configure our map shape. By selecting a new destination profile, which will be the customer model from Hub, we can use Boomi Suggest to expedite our mapping and complete the CRM to master data hub process. And for our second process, we'll be going through the same steps, this time configuring our MDH connector as a source application and NetSuite being our destination.
Francium is working with a third-party company to develop a mobile application for customers and partners. One of the features they would like the application to support is placing an order. To enable the developers to provide this functionality, Francium will use Boomi's API feature. The API will allow for orders to be placed in their ERP system and provide access and control metering, giving Francium full control over what the developers in the application have access to.
Creating APIs in Boomi is quick and easy with our configuration-based approach. Today, we'll be creating an API that allows Francium to create sales orders in their ERP system, which can be triggered outside of the Boomi platform. Similar to how we repurposed our integration process for the EDI and Master Data Hub demo builds, we can do the same to turn a Boomi process into an API. Creating APIs this way with Boomi, in simple terms, is a two-step process. First, we'll convert it from a batch-oriented process to a web server by changing our start shape. Web services server connections must be the start shape. I'll allow Boomi to make the recommended changes for me and keep the action to listen. Next, let's configure the operation. The operation represents the incoming payload from API requests, which is in conjunction with creating a sales order. For our operation type, we can change that to create, and our object will be create sales order. For expected input type, I'll select single JSON object and create a simple profile. From here, I have the option of importing a JSON file to automatically build my profile, or I could do it manually myself. For demonstration purposes, I'll manually create a simple profile. Every ERP is different, so the structure of this profile will vary per the ERP's requirements in terms of what is needed to generate a sales order. But once the profile has been created, the configuration of our web service is done. Moving back to the build canvas, I can delete my Salesforce shape and then update the map to reflect our new source profile. Again, I'll be using Boomi Suggest to automatically generate my mappings. Next, I'll click the blue New button in the top left corner to create a new component of type API. And for the API type, that will remain API service. Now begins the configuration of our API specifically. First, give the API a name, version, and description, and then establish what your base API path will be. The full URL of our API depends on the location we deploy this service. So our main focus today is the endpoints that retrieve data. We have the options of defining either a REST, SOAP, or OData based API but today we'll be creating a REST-based API. The various layers of the Boomi platform work together as we've seen in our other demos. When it comes to creating the various endpoints for our API, I have a few options. I can import a service file or service URL, or I can ultimately leverage an existing component like the web service process we just created. So by using an existing process, I've turned my web service into a REST-based API endpoint. Through this, the platform does the rest of the work for me. But let's review what was automatically generated. My resource path, HTTP method, and input type has been automatically defined. The profile we created to handle the incoming requests has also been attached to this endpoint. The process we just built is meant to create a sales order, but that's only one endpoint. With the same steps we took, we can easily build more processes to act as additional endpoints. Rather than creating a sales order, we could build an endpoint that queries all the sales orders along with adding search parameters as well. But for now, we'll just stick to one endpoint. From here, we can move on to the API management layer of the platform by navigating through the Services tab. Boomi API Management provides the ability to create and deploy a gateway in order to route traffic, configure plans for API governance control, and handle authentication either with the Boomi platform or a third-party authentication provider. Let's jump into the self-service developer portal and take a look at the API that we just created. The homepage of the developer portal can be customized and shows us all our available APIs. Here, I have the ability to subscribe, authenticate via an API key, and use the APIs directly in the Boomi platform.
Francium is becoming a data-driven business. They've established a data lake where data from multiple sources is stored. While the data is very useful, the request for data views is becoming overwhelming and causing delays, which affects the timeliness of business reports.
Using Boomi Flow, we'll build a front end to surface our data with a web-native user interface that enables business users to view and interact with the data. While Boomi Flow has many uses, today we'll be creating a simple dashboard that connects to a data source and provides a web-based view. Flow has a slightly different look and feel, but still carries the same DNA as the rest of the platform. A drag and drop experience that's configuration based versus manual coding. To begin, let's create a new flow, and I'll title this Sales Dashboard. First, let's grab a page component, which will act as our main dashboard page. We'll give it a name of Sales Dashboard, then click New Page Layout. Next, let's create some text for this page to welcome new users who access it. And to do that, I'll use a presentation component. Once we drag and drop that into the main container, the ability to type and display text on the screen pops up. I'll name this component header, and then for the content, I'll just type up a nice little welcome screen. Nextly, we'll drag a table component and drop that into the main container underneath our presentation header. I'll name this Orders. I'll select data source and choose the query order details from DB option. Boomi Flow has native integrations with various applications such as a SQL database. But by leveraging the power of the Boomi integration layer, we're effectively able to access any application and present that data. The data source we choose here defines how Flow will access the data. In this example, we're leveraging an integration process which is connected to a database or a data lake that we then can display data in real time using Boomi Flow. I'm going to select Get the Data from a service, and the binding will be Query Order Details from DB Binding. Next, let's define the state, which is used to handle selections the end users make. By choosing Selected Order, I'm ensuring we show information about the proper order and end user selected. And lastly, let's configure how the table will be shown. This is handled by the data presentation section. And to start, we'll add a few columns, which are representative of our database columns. And for each column, we'll have the same settings. After that, we're done configuring the table. Before we give this flow a test, let's create an outcome between the start shape and our page shape. To do this, I'll hover over the start shape. And once it turns green, I can drag and drop the arrow over the page shape to create an outcome. And I'll give it a name of Go. Now, by running the flow, we can take a look at the work we've done so far. The next component we'll set up is the details page. This will allow us to dive into each order entry and view additional information. We'll be creating another page, so I'll drag and drop that component onto the canvas. This time, let's create additional containers for organization purposes. We'll start with the presentation component again and drop that into the header container. And this time, when typing up our text, we'll use dynamic values. So each order you select has a respective order number being shown. By using the insert value button, I can add these dynamic variables. I'll create another container named order details. And this time, I'm going to change it from rows to columns. This setting dictates how components placed inside the container will be organized. I'll drag and drop 3 input components into this new container to create inputs for the status, customer, and order total fields. For each of these configurations, we'll leverage that same state value that we used previously, which allows us to capture user level selections. And again, this just ensures that they are presented with the accurate information. The last step of our order details page, I'm going to add a table to present each of the line items that are on each of the sales orders. The process is mostly identical to the steps we took for the table configured for the sales dashboard page. But with that completed, the order details page is done, and we can jump back to the canvas to create an outcome between the 2 pages. By default, outcomes appear at the bottom of each of your pages. If you want our outcome or the button to appear within a specific component or table, we can configure this option by expanding the advanced section and changing the appearance. Under appearance, we have the option to choose orders in that drop-down menu for flow to place our details outcome in the orders table that we built earlier. While we made a very simple flow today, the possibilities are endless. Through the flexibility and ease of use, Boomi Flow is meant to automate, enable, and empower your business and data.